Okay, so now welcome back. Now, here's a situation that is reminiscent to what we had discussed at the very beginning when we started this this section, if you will, on solving trigonometric equations. And we said, you know, a lot of the stuff is going to be algebra and dealing with how to solve these algebraically. So this is one of them. So notice that this is quadratic in form. And so I'm going to just do a u substitution, and I'm going to replace cosine with a variable and then just deal with the algebra. And then when I solve for the u, the variable that I'm substituting, then I will go back to theta. Okay, everything in terms of theta. Now, so I'm going to say, okay, let u equal cosine theta. And so what's going to happen is this is going to be transformed into u squared plus 3u minus 1 is equal to 0. And so now we have a quadratic equation, right? So a lot of times now, if you can deal with this without the u substitution, fine. But a lot of times for students, they get confused like, okay, well, how do I deal with this? I've got the cosine theta, blah, blah, blah. So what happens is, just to simplify things for you, just do a u substitution. Now you can just focus on a quadratic equation that you should know how to factor. So again, here's where I'm going to use the AC method, or excuse me. So I've got -1. Okay, so I've got, well, let's see here. Well, okay, so actually looking at this, there is no, right? So we want to find two factors of -1 that will add up to 3. Well, there are none. So guess what? This is not factorable using whole numbers or integers. So we're going to have to use the quadratic formula. So we're going to say u is equal to, well, again, it's going to be -3 plus or minus the square root of 3 squared minus 4 times 1 times -1 all over 2 times 1. Okay? And again, you should know the quadratic formula at this stage of the game. Okay? So -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? So now, let's just simplify. That's all we have to do is simplify at this point. So we have -3 plus or minus the square root. Well, this is going to be 9 plus 4, which is going to give us square root of 13. That's not going to help us. So that's going to be -3 plus or minus the square root of 13 over 2. So there's our exact answer. Now, we're not done. Okay? Now, let's look at this. Okay? So we've got two possible answers. Okay? So we've got two possible answers here. So let's go back and substitute in. So now what we're getting at is this is equal to cosine theta. Okay? So cosine theta is equal to this. -3 plus or minus the square root of 13 divided by 2. Okay, now, now here's the thing you have to realize. We're going to use the calculator here, but we're going to get an error when we use the negative, when we use the subtraction. Okay? So because we're going to end up using the calculator on this, and again, the obvious reason is because we don't get something that's nice and easy, doesn't give us a nice right triangle to use. So we're going to have to take the inverse cosine of both sides. So we're going to have theta is equal to cosine inverse of -3 plus or minus the square root of 13 over 2. Now, the reason why we're not going to use the negative sign, we're only going to use plus, is because if we use the negative sign, we're going to get an error on our calculator because the domain of the inverse function, remember, the range of cosine is from -1 to 1, which means the inverse function domain is -1 to 1. And so if we put the negative sign, that's going to put us over -1 or less than -1. And so that we'll get an error, a domain error for our calculator. So, but if we put plus, then we get a subtraction. If we leave it as plus, we get a difference on top, which is going to put us less than 1. Okay? So that's why, just to explain that. So now there is a second solution though, okay? But we have to find the first one, right? And then we'll be able to find the second one. Okay, so now let's find the angle. And the reason is because cosine is equal to this, right? And so depending on the value of what this is, there's going to be two solutions because we have the plus minus. So there are two solutions. We're just going to have to find one and then we'll find the other one. Okay? Okay, so now let's get the calculator. Oh, and I left my calculator. Okay, so you're going to stick the calculator. So again, you're going to use inverse function, the inverse key on your, the inverse function on your calculator. So it's going to be second cosine. So typically, again, you have a cosine key, and if you use the second key with the cosine key, you'll get the cosine inverse. Okay, so you take this on your calculator, and that should give you approximately what? 1.26. So this is going to be approximately equal to 1.26, and that's radians, of course. So make sure, again, that's in radians. Now, if you have degree mode, it'll give you degrees. If you don't have, if you only have radians, then you'll have to transform it into degrees using the conversion factor of 180 over pi. Okay, but again, since this is a ratio, then you can use the radians and then, of course, again, convert it into degrees. Okay, so now, where does this end? Okay, so again, notice that this is less than 1.57. Remember, pi over 2 is approximately 1.57, so it's less than 1.57, greater than 0. So this is obviously in the first quadrant. Okay, so now, since cosine is also positive in the fourth quadrant, right? So again, notice the range of the domain that we're interested in for theta. So the first solution is 1.26, which is in the first quadrant. Okay? So now, it's positive. We also know, oh, hold on a second. Well, if you put this in your calculator, you're going to get a positive value. And why do I know that? Think about it. What is the largest perfect square that's less than 13? It's 9. So we know that this 9 is, the square root of 9 is 3, which would make this 0. So we know that this is larger than 3, which means that this difference here, -3 plus this, is going to be bigger than 0. It's going to be positive. which means we're going to get a positive value here. Okay? Now, if it's negative, right, if we're doing a subtraction, then we're going to get a negative value here. And cosine is negative where? It's going to be negative in the second and third quadrant, and it's positive in the first and fourth quadrant. So again, knowing that is going to help you figure out what the solutions are going to be. Okay, so anyway, let's get back to this. Okay, so now, since the terminal side is in the first quadrant, we know that this is going to be positive. Okay, so this is going to be positive also in the fourth quadrant, which means, guess what? We're going to 2 pi. So we're going to subtract this 1.26, because think about it. Again, I do this just to make sure that all of you understand. So I'm going to have up here, right? So we got this angle. This is in radians. I'm dealing with radians. So this is 1.26 approximately. Well, we know that the other is a reflection across the x-axis in the fourth quadrant, and it's basically negative 1.26. Well, what is 2 pi? Well, 2 pi is about 6.28. So what I'm going to do is I'm going to take 6.28 and I'm going to subtract off the 1.26, and what do I get? I get 5.02 as my angle. So that's the other angle is approximately 5.02. And there you have it. So theta is equal to 1.26 and, for the two solutions is 5.02. Now those are in radians, right? Okay? And I'm going to leave them in radians. Now, the other thing too is we did not use the negative because why? It's outside the domain for inverse. Okay? Okay, that's it. Have a great day.